Okay, before I give you exams, let's do one example, which is like just part of the review. The last example in 5.3. It's also part of the review for the final. So how can we get A, which is equals to PDP inverse? How should we get that? Okay, so you follow the steps that we wrote. So first of all, you need to get the number one, find the eigen space corresponding to eigen values corresponding to eigenvalues. So you start by getting the eigenvalues, and after that, then you get the eigenspaces corresponding to the eigenvalues. So here it is so easy to get the eigenvalues. So the eigenvalues, you get it from the diagonal there. So it means so it will be 1 minus lambda 0, 0, 2 minus 1 minus lambda 0, 4, 6, 2 minus lambda. Then now you get the determinant here, which is 1 minus lambda 0, 0, 2 minus 1 minus lambda 0, and then 4, 6, 2 minus lambda. So the determinant there is giving us the characteristic polynomial. So the determinant, then characteristic polynomial, will now be equals to minus 1 minus lambda, minus 1 minus lambda, and then 2 minus lambda. 2 minus lambda. So the characteristic equation will now be 1 minus lambda minus 1 minus lambda, and then 2 minus lambda equals to 0. So then using the zero product property, then lambda equals to 1. So you can name this one as lambda 1, lambda 2 equals to minus 1, and lambda 3 equals to 2. So we now have the eigenvalues. Now let's get the eigenspaces corresponding to the eigenvalues. So let's get the eigenspaces corresponding to the eigenvalues. Now let's start from the first one. When lambda 1 equals to 1. So when lambda 1 equals to 1, then we now come and replace where there is lambda here to be equals to be 1. So we replace where there is lambda 1 as 1. So when we replace this, then what we get is 1 minus 1, 0, 0, 2 minus 1 minus 1, 0, 4, 6, 2 minus 1. Then what we get here is 0, 0, 0, 2 minus 2, 0, and then 4, 6, and 1. 4, 6, and 1. Okay. Then from there, then we do what? So we actually want to get this is, we want to get equals to 0. So we want to get the solution there. So we want to get a solution there. So all you need to do is we want to reduce this. So then when we write this in augmented matrix form, then we get 0, 0, 0, 0, 2 minus 2, 0, and then 0, and then 4, 6, 1, and then 0. 4, 6, 1, and 0. So what we do here, we just switch the last one and the first one. So you switch. So you switch R1 and R3. So when you switch R1 and R3, so 4, 6, 1, 0, and then 2 minus 2, 0, 0, and then 0, 0, 0, and then 0. No, we could have just switch. Let's just switch 1 and let's just switch 1. Yeah, so let's just switch. So let's switch this one to come up here, this second one to come to the second one, and then the last one to go down there. So when we switch all of that, then we can get 2 minus 2, 0, 0, and then 4, 6, 1, 0, and then 0, 0, 0, and then 0. So we can switch. Then you now reduce completely. So you now reduce completely. So you can make this, you divide everywhere by 2 here. And then when you reduce this one, then what you get, finally what you get is, so what you get when you solve completely is 1, 0, 1 over 10, 0, and then 0, 1, 1 over 10, 0, and then 0, 0, 0, and then 0. So that is what. So we have our basic variable there. So our basic variable is x1 and x2. Our free variable is x3. Free variable is x3. So then x1 plus 1 over 10 x3 equals to 0. x2 plus 1 over 10 x3 equals to 0. So our solution set, so then x1 equals to minus 1 over 10 x3, x2 equals to 1 over 10 x3 minus. So our solution set is now our x equals to x1, x2, x3, which we now get so minus 1 over 10 x3, and then minus 1 over 10 x3, and then x3 as our free variable. So when we factor out x3, then we get minus 1 over 10, minus 1 over 10, and then 1, and then 1. So that's what. So that is how to get that. For what? For any x3. Now, doing the same thing for the others. So for the x, for the lambda equals to minus 1. The lambda equals to minus 1. Then the same way we did. So you replace 1 minus 1 and then minus 1 again. So it will be plus 1, which is 0, 0. And then 2 minus 1 plus 1, 0. And then 4, 6. And then 2 plus 1. 2 plus 1. So definitely what you get here is that one is 2, 0, 0, 2, and then 0, 0, and then 4, 6, and 3. 4, 6, and 3. So when you write the augmented, so this is like that equals to 0. So when you write the augmented matrix form, then you get 2, 0, 0, 0, 2, 0, 0, 0, and then 4, 6, 3, 4, 6, 3. 3 and then 0 there. So when you reduce this completely, then what you get is 1, 0, 0, 0, 0, 1, 1 over 2, 0, and then 0, 0, 0, and then 0. So that is what you will get. So our solution set will now be x equals to 0, since x1 is 0, and then 1 over 2, which is x3, and then x3. So which is the same as x3, 0 minus 1 over 2, and then 1 for any x3, for any x3. So the same thing for lambda equals to 2, lambda 3 equals to 2. Lambda 3 equals to 2. Then for lambda 3 equals to 2, for lambda 3 equals to 2, so what you should get is the solution set x equals to x1, x2, and then x3, which is the same as 0, 0, x3. Then finally, what you get is x3, then 0, 0, and then 1, x3. And then for what? For any x3, for any x3. So we have now solved the eigenspaces. This one, the other one. Now our P, we now get our P from the eigenspaces. So our P is now equals to, for lambda 1, so for lambda 1, we got, so what you can do, you can just, before you write this, so you can just write the eigen values and then multiplicities and then eigen spaces. Eigenspaces. So when when eigenvalue is 1, multiplicities are 1. So then, since you have this as 1 over 10, and negative 1 over 10, negative 1 over 10 there. So we can multiply both sides by what? By 10. So what you get here is negative 1, and then 10 there. So that is our eigenspace. Or you can multiply by eigenvalue. And then when eigenvalues, when the next one is negative 1, multiplicities are 1. And then what we got for negative 1 is this one here. So again, we can multiply this by 2. So what we get there is 0, and then negative 1 and 2 there. And then finally, when it is 2, then multiplicities are 1, And then finally we have 0, 0, and then 1, 0, 0. So then our P is now, we take now this. So -1, -1, and then 10, 0, -1, and then 2, and then 0, 0, and 1, 0, 0, and 1. So that is all. Now our D, we now take the what? Our D, we now take the eigenvalues. So our D, so you arrange them according to the eigenspaces. So our D here will now be 1, 0, 0. The next one is 0, -1, 0. And then the last one there is 0, 0, and then 2, 0, 0. Right. So that is our P. So as long as you get this and that one, then you don't have to prove. So you don't have to prove whether A equals to P, D, P inverse. So you don't have to prove that because it's, you need to get the inverse of this. Oh, the easiest way to do that is AP. So you can multiply here by P, and then you can also multiply here by P. So AP equals to PD. So you can prove this. So you can actually multiply A and P, and then P and D to see whether they are equal. See whether. Any question after that? So you should expect a question on 5 or 3 on something like this in your framework. Okay. All right. Let me give you. Awesome. Right. Right. So if you have any issues, I'm available anytime. So let's go through this. It wasn't very hard. It was trickier, but it was not hard. Okay, so I gave you a leakage on the first one, and most of you did not do so. And so this is part of the to 0 at the time. So, okay. These are also in your notes, so make sure you check them. I also gave you something like this. So some of you missed the point here. So when you have the determinant of 3 here, of 3a, so this is the same as factoring out these 3 and then raising to the power of, this is a 4 by 4. So you raise to 4 and then determinant of a, determinant of a, okay? And this is the same as 3 raised to 4. Determinant of a is -3, which is the same as -3. 3 raised to 4, which is also the same as -3 raised to 5. 3 raised to 5. This is the same thing. So these ones, I think all of you do it, but one which most of you have an issue is. Okay. The next one, I did it like twice, so I know it was tedious for most of you. You get a determinant. So getting the determinant, you can actually use the one which has as many zeros as possible. So you can either use the last one here, or you can use the second here. Again, make sure some of you are having an issue with the sign. So again, do not miss the point on the signs, So the signs are an issue. So make sure you put it correctly. So make sure you put it correctly. So finally, the determinant should be -30. So I give most of you some. If you're getting less than 100 in your determinant there, so you get more than half of the things. Okay, so if the determinant is not equal to 0, then definitely it is what? Invertible. It is invertible. So if it is invertible, then definitely it's linearly independent. So it is linearly independent. Linearly independent. Okay, that was it. Again, here, most of you did not get a point here correctly. So using I gave you a hint here. So use the Cramer's rule. So you get A and then you get B. So A again are the coefficient. So this is the coefficient matrix. So this is the coefficient matrix. So you get a coefficient matrix and then you get our B there. So the determinant of A here is now getting that multiply this and this minus this, and so what you get is that. So that is now x1. You now replace the first one here with that B there, and then you get the determinant. So when you get a determinant of this, so you get -12 plus 6. So -12 plus 6. So you can factor out 6 there. So when you factor out 6, then it is 6 and then t minus 2. Since this one is 3t minus 2 there and t plus 2 there, then you do what? You divide by that. And then t minus 2 will this cancel. And then 3 and 2 there. So you get 2. And then since we want to get exactly one solution, then this t here should not be equal to -2. So it should not be equal to -2. Same thing to this. Replace that with that, you get 2 and then minus t. So you factor out the minus. So you factor out the minus, then it will be t and then minus 2. So t minus 2 will cancel with t minus 2 down. And then you get that minus 1. Where t is not equal to minus 2. So those are the values of x1 and x2. Okay. All right, so number 4, getting the determinant using the cofactors. So you can get the cofactors fast. So you get C11. So you arrange it like this for you to make it so easy. So you get C11, C12, C13, C21, C22, C. Like that. So compute the determinant by cofactor expansion down the first column. So the first column is this. So it will definitely be this. So you now take this. This one multiplied by 0. And then 7 multiplied by 23. And then 5 multiplied by 1. So you solve that. So the adjoint is now taking this as the what? This one as the first row. Okay. So you can actually write this like 2, 14 and 10 like that, but you must do what? You get a transpose. So you can either write these 2, 14 and 10, and this one and that and that and that one and that and that one, and then you put a transpose there. You get it like this. Or you can just come and write this. So you put this one, 2, 7, and then 5. That's the first one. 14, 3, and 9 as the second one. And then 10, and then 4, as well as the first one. Okay. And then finally, you don't have to solve anything. So you just put A inverse is like 1 over the determinant multiplied by the adjoint. Okay. The next one here. So you use the subspace test. Easiest way to do is if you replace A1, A, B, and C by zeros. Okay. If you replace all these by zeros, you will still get 0, 0, 0, right? You still get 0, 0, 0. So if you get 0, 0, if you don't get 0, 0, 0, like this, if you replace A and B by 0, 0, and you don't get 0, 0, 0, then this is not the subspace. So you just leave it one. So you don't have to solve a lot of issues there. So the first one is use the subspace test, whereby 0 here, 0 vector, is an element of H. So that is the first thing that you need to do. And then the next one is you can now, if 0 vector is not an element of, is an element of H, then you can go to the next step. If it is not, then you stop. So you just say it is not a subspace. Just like this, we don't do anything else. And then again, this one, look at this. So you now, since these are 0, 0, then you can factor out A that. So the span of that. So these are in, so these are in H. So this in H. So this is not in H because we have 0, 2, and 0. So it's not in. And then finally, here. Again, using the same thing, using the subspace test. You put 0, 0, 0 here, and 0, 0, 0 here, you get 0. So using the same thing that we've done there. you can go to the next step, which will give you the subspace of subspace. So go and check again on the subspace. You'll get one question in your final. Okay. This one show that the polynomial P1, P2, P3 are linearly independent. We did this one severally. So first of all, since we want to know that these are equals to 0, then we multiply it by that constant, and then factor out, and then now we put as this, and then we write it as a matrix, and then we reduce it. So if all the columns have private position, then it has trivial solutions. So it is linearly independent. So it is linearly independent, so it has a basis. So then again, when you come and solve this, using the same way, you already solved this here. So you now equate it to what? 40 plus 60 equals to 4. And then you come and solve the values of C1, C2, and C3. The same things. So what you should get is C1 is 3, C2 is 4, and so once you already solve this, then it's easy to solve it. So you just transfer. And okay. So our order, they call it B coordinate there is now the solution here, which is 3, -4, -1, -4, 3, 1. So this is C1, C2. Okay. So that is how to solve that. Number 7. So I already gave you the column space matrix there, which is this. And then you now row reduce the matrix. In fact, this one is only to echelon 4. So it is not reduced to reduce echelon 4. Just echelon 4. So just reduce that. So when you reduce that, you get. So the basis is a column space of A. So you just get what? The ones which are given with the high definition. So this is. So that's the dimension is the number of vectors in axis. The dimension of the column space is 2. Okay. This one I expected you to have read the notes. This one, so all of this is, all it's in one notes. So you go through this one. Go through. Okay. Let me give you. I'm not posted this one. Okay, so this time around, I'll allow you to come with cheat sheet. So you come with a small one. So just this side. Just a small card. So I can allow you to write on this side. So don't write a lot of things. So just write some basics like how to get the terminal, or the small things that you feel like they might come in the exams. So you don't have to write a lot. So write the things which you're not feeling so comfortable with them. Okay, so just come with 3.3 3 by 5 not count. So the exam will be comprehensive. So since I did not give you an exam of this, so expect like 1%. So 1%. Chapter 5, you will get 1% here. So you should know how to get A equals to P dP inverse. So how to will not be hard. So the exam will take you 2 hours. So it will be 2 hours. And it is 150 points. And the time is 7:30 to 9:30 on Monday. So on Monday. Please do not forget. So the exam is at 7:30. So the exam is in class. So the exam will be here. The exam will be here. So you'll just come with a note card, no calculators, no textbook, no exercise book. So you just come with your calculator. Don't come with your calculator. Just come with your note card. So what we did in chapter 1, 2, 3, and 4. If you just read your notes, then I am so sure you will pass this exam. I'm very sure. So everything is in our notes. It's in our notes. So you can also go through the review for exam 1 and exam 2 and this exam 3. And also you have the solutions there. You have the solutions. So I'll pick some few questions, just similar to the ones which you had in exam 1, 2, and 3. Similar questions. The only difference is this chapter 5, which you get 1 question. Okay, so these are the sample exams, sample questions that you will get in the exam. The answers are at the back. So the answers are here. If you have any question, then I'm always available. I will be available over the weekend. So if you have any issues, I think I'll be in the library the whole day tomorrow. So if you have any issues, you can meet me there. Okay, let's see some of the things that you may get. So number 1 there is, so we have done actually most of the things which are related to this. So it will be so easy for you to get to solve this. So first of all, you need to know what you need to know is you need to get a solution where you can have infinitely many solutions. Number 2, distinct or 1 solution. And then number 3, no solution. No solution. So you need to remember how to do it. Have that in our- The second one here, that's the way we just did. That's one example. So just the same as what is in our example. So first of all, you use a subspace test. Next one and x2. So actually, this one is taking us to here. So find t, 3, -2, and 1. So x1 is 3, x2 is -2, and x3 is 1. So you just go on. Find the standard matches. Remember how to write the standard matches. Find all the vectors. This one says that t is equals to 3. So you need to know how to solve this. So find all the vectors. Find the solution. Find the solution for x2. This by A plus B, how do you add? So the number of rows, the number of columns here should be equal to the number of rows for it to add or multiply. So you should know how to get A inverse of 2 by 2. Okay, I gave you something. Did I give you something like this in the exam? What's the exam two? Or this one?
It's in the review for
So you'll read that review, right? I did not give you anything in exam. So I think I'll do this. So find, remember, to allocate the data. So this will be in your final result. So remember how to get the null space of A, how to get the column space of A. This one is the easiest actually. This and this and this. So this one, this and this is the easiest. So if you're solving something like this, start if you're doing this exam can take you a lot of time since you're not using that. Please start from the things that are so easy so that you don't waste your time, especially getting the determinant, like getting the determinant of something like this. You can leave this one for the last one, but solve takes like small things like this one spot. That can take you like 1 minute to solve it. So like this can actually take you like 1 minute to solve it because you just reduce this sort of echelon form. So the ones which are giving you the pivot positions are the what? The basis for the column space. And then the dimension of the column space are the number of those vectors which are giving you the rank is the dimension of what? The rank is the dimension of the column. Okay, so that is the rank. Null space can take a lot of time. So null space is where you're getting what? Null space is where you're solving AX equals to 0. So you're solving AX equals to 0. So you want to get the vectors, these solutions of X. So once you've done the column space, then you can actually the echelon form just come and add the 0, 0, 0s, and then you reduce it completely. You get the null space. Again, this one is easy. I don't give you something like this. Or did I give you something like this? So if it was in the review, okay. You have that. If you switch, it should be negative. If you add like this ascend, doesn't change. If you must have a constant 2 there, you factor out 2. Okay, number 6. So option A, B, this one, and then compute determinant of A by using cofactors expansion. So that can take a lot of time. So, but it is not very hard. So you just look at the rows or the columns which has as many zeros as possible. And then is A invertible matrix? That is easy. Once you get the determinant, so definitely it is invertible. Are the columns of A linearly independent? If you get the determinant, definitely they are linearly independent. Number 7 there. So if you just look at it here, so which one, if you just look at it without even solving, which one is a subspace of R3 and which one is not? If you just look at it, is the first one a subspace? No, it is not. So the second one is a subspace, and the last one is a subspace. Yeah. Okay. Number 8. Number 8 is just similar to what we did in our exams, so it is the same thing. Number 9 here. Number 9 is also similar to number 8. Number 10 here. Yep. So number 11 is just similar. So number 11 again. Number 11 here. Suppose the characteristic polynomial is this. Find n. So what is n? It's the highest power, right? And the highest power here is 6, and n will be 6. And then find the determinant. So what will be the determinant? So what did we say about the determinant? You replace lambda by what? 0. So the determinant here will be 0. The determinant will be 0. And then find all the eigenvalues. Eigenvalues is solving. Now you need to solve that. And then is A invertible matrix. If the determinant is 0, is it invertible? It is singular matrix. Number 12, if you have this D and P, find all the eigenvalues of A. So what are the eigenvalues of A? Without even solving it. It is this, and this one. This, and this. Use the algorithm for inverse matrix to find P inverse. Get the P inverse of this. You remember how to get the P inverse over 3 by 3. You multiply by what? Put another 3 by 3 identity matrix next year. Then we will use it. The one which you get here is our inverse. And then find AK. So AK, you remember we say AK is the same as PDK and then P inverse. So for this, you remember the similarity. The similarity, right? So it is in your notes. How should we get AKP? So it should actually be what is. Since this one is similar to this, then it should be what? A raised to k, 3 raised to k, and then what? Since they are okay. Then last one here is the third one, find the eigenvalues of A. So, any question? Any question? So
I have a question on the chat. How many questions are we expecting for the final exams?
I'm not so sure because I've already set like 3 questions. So I will solve them to see whether you can do it within 2 hours. So it is something that you can do within 2 hours. So it is something that you can do within 2 hours, okay?
Okay.
Either it will be 4, 5, something like that, or 10, as long as you can do it within 2 hours. All right, so if you have any question, then have office hours anytime you can come around.
Are we supposed to email you about the course evaluation?
Yeah, just email me and then
Okay.
you will get 5 points.
Yeah, I can remember there's so many professors doing different stuff with the course evaluation.
Yeah.
Thank you.
All right.